students, let us come back to our probability theory. Again, we are coming to the last section of this probability theory, that is random variable and probability distribution. I will explain to you what is a random variable and what is probability distribution. And in addition to this, in our textbook there are three more things, that is mean and variance of probability distribution, and there is another one, that is Bernoulli theory. Okay, Bernoulli trials. So those who study for entrance exam and other things, you can go through your textbook. In CBSE syllabus we will finish here. So the last section is random variable and probability distribution. And for this random variable, first of all you have to find out what is meant by a random variable. I will explain very simply. Look at this. You consider the experiment of tossing a coin 3 times. As you know, how many sample points are in sample space? Look at this. Consider as 3H, HHH, HTT, HTH, THH and HTT. These are the 8 outcomes you already know. Okay. Now, let us find out the number of heads in each case. Now you concentrate on the number of heads in each case. There are 8 cases and you count the number of heads. So look at the first one. There are 3 H. So the number of heads is 3. Then you take the next 3 elements or sample points, HHT, HTH, THH. How many heads are there? There are 2 heads actually. And what about the last one, that is TTT? There are no heads, so you have to take it as 0. And in the third case, HTT, THT, THH, there are only 1 head. So these are the number of heads in each case. So the values arise 0, 1, 2, 3. That is corresponding to each outcome in S. We can associate a real number. That is very important. So when you consider each outcome, you can associate a real number. That is 0, 1, 2, 3. If you define a variable x, so the values are varying. It may be 0, 1, 2 or 3. So you can define a variable. If you define a variable x which can take values 0, 1, 2, 3, then that variable is called a random variable. Okay, got the idea? Once again you go through what are the different number of heads. They are 0, 1, 2, 3 or 3, 2, 1, 0. So you assign a variable to that is x. Suppose x can take values 0, 1, 2, 3. Then we say that x is random variable. Okay, that is the definition for random variable. You can write a random variable is a real valued function whose domain is the sample space of random experiment. So actually it is a function, a real valued function. And what is its domain? Its domain is sample space of random experiment. So this is the domain. And we associate each sample point to a particular real number. So it is a function. Okay, read it once again. It is very simple. Now, how to write the probability distribution of a random variable? That is what we are going to study here. Here also, like x is a random variable. Here you need how to consider x. X is a random variable associated with a sample space. There is always sample space and this random variable is associated with S. Suppose x can take values. X can take values x1, x2, x3, x4, etc. xn. Just like 0, 1, 2, 3. There may be n values. When the experiment changes, the number of heads or tail may change. So you can take x1, x2, x3, x4, etc. xn. These are the values that can be given to capital X. And there is also probability. Look at this with the probabilities. The probability of x1. You can take it as P1. The probability of x2. That means when capital X is replaced by x2, what is its probability? You can take it as P2. Then P3, X3, P3, etc. Pn. Okay. Now, in this case, all the probabilities come. That is P1, P2, P3, etc. plus Pn is equal to 1. You have to remember this. when you write down a probability distribution in the first column, in the first row you have to write x1, x2, x3, etc. xn. That is all possible values of x you have to write there. And in the second row, corresponding to each column, you have to write its probability. For example, in the first experiment, that is when you toss a coin 3 times, the number of heads we done 0, 1, 2, 3. Okay, if it is 0, that means there is no head. And how many favorable cases are there? Only one, that is T. So answer is 1 by 8. And if you are considering all the 3 heads, the random variable is 3. If it is 3, the probability is 1 by 8. And if it is 2, how many 2 heads cases are there? There are 3. So you can write 3 by 8. And if 1 head, there are 3. So you can write it as 3 by 8. So total probability is 1. Here also you have to remember that. Otherwise you can write sigma pi is equal to 1. And I varies from 1 to n. Okay. Here you have to remember that probability of x1 is p1. Probability of x2 is p2 and so on. The above table gives the probability distribution of x. So when they ask in examination, write down the probability distribution. What you have to do? You make a table, you prepare a table. And in that table, on the left side, you write capital X and probability of x. Then each column, you write the respective values or variable values and also write the probability. That's all. Then you take down this. Check whether P1, P2, P3, etc. Pn is equal to 1. Now let us come back to the previous example. S is equal to HH. That means a coin is tossed in 3 times and you know the sample space. Now we define a random variable. This is random variable, capital X. Let X denotes the number of heads appear. Then X can take values. The number of heads may be 0, 1, 2, 3. So we write all the 4 values 0, 1, 2, 3. Now you have to consider each case. What is the probability of x is equal to 0? That means in that case there are no heads. So how many outcomes are favorable to it? There is only one, you know. So answer is 1 by 8. And second case, that is number of heads is 1. How many outcomes are favorable to 1? You can see there are 3 outcomes in the sample space. Look at the sample space. There are 3 outcomes favorable to 1 head. And that case, that is probability of x is equal to 2. That means the number of heads is 2. How many outcomes are there favorable to 2 heads? You can see 3 outcomes. So answer is 3 by 8. Then we come to the last one, that is probability of 3 heads. How many 3 heads are there? There you can see only 1 outcome favorable to it. So answer is probability of x is equal to 3 is 1 by 8. So this is the way of finding the respective probabilities of random variable. Now what you have to do is, after finding all this, you have to prepare a table. That is our probability distribution. Okay, once again, the probability distribution of x is given by, you write capital X here, then the corresponding values, that is 0, 1, 2, 3. Then you write the respective probabilities in the below. That is 0, 1 by 8, 1, 3 by 8, 2, 3 by 8 and 3, 1 by 8 from this. Okay. Now you can check whether your answer is correct or not. For that, what you have to do is, you take all the probabilities and take their sum. So okay, 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8. If its sum is 1, your answer is correct. If there are any change, you have to go through the previous things you have written here. Okay. So you have to check the answer whether it is correct or not in each case. If you are doing a problem related to probability distribution, after preparing that table, you have to check whether it is correct or not. What the idea? Now there is another question. This question is also important. I have done it for you and I will explain it. And it may be in your textbook. The problem is there. You can do it yourself. When you are doing this problem, let us first of all read what is it. From a lot of 30 birds, which includes 6 defectives, So in 30 bulbs, 6 are defective and 24, as you know, they are good bulbs. A sample of 4 bulbs is drawn at random with the replacement. So we are taking a sample of 4 bulbs with the replacement. Find the probability distribution of the number of defective bulbs. So here you have to concentrate on the number of defective bulbs. That is our random variable. Number of defective bulbs. Okay, how many bulbs we take? We take only 4 bulbs. So you know what are the required numbers. There may be 0 defective and 4 good bulbs. You go through the different cases. The first case is 0 defective and 4 good bulbs. Then second case 2 defective and 2 good bulbs. And 3 defective and 1 good. Then 4 defective and 0 good bulbs. So there are 5 cases. So before doing the problem, we have to consider the different cases. What are the possibilities there? So we have listed 5 different cases. Now come on the first one, 0 defective and 4 good bulbs. So we are taking 4 bulbs one by one after another. So in the first draw, it may be a good bulb. The second case also good bulb. Third case also good bulb. Like that. So what is the probability of x is equal to 0? So here I have to consider combination. See in the first case. That is in 4 ways you can do it. So you have to multiply it using 4. That is probability of x is equal to 0. 0 means 0 defective. We are not taking defective bulbs. All are good bulbs. So you know the probability 24 by 30. There are 24 good bulbs and total there are 30. So answer is 4C0 into first draw. That is 24 by 30. Since you are replacing the ball, the probability does not change. Again it is the same. That is 24 by 30. Then again it is 24 by 30. So you simplify it, you will get answer as 256 divided by 625. Okay, that is the case of 0 defective. Now you come to the second case, that is 1 defective and 3 good bulbs. So how many ways you can select 1 defective? We can select in 4C1 ways. That is why we have written 4C1 there. So when probability of x is equal to 1, you have to start with the 4C1 into, and 1 defective means we are taking only 1 defective and all the others are good bulbs. So how will you write the probability? You know the probability of defective is 6 by 30 and the remaining bulbs are good. So how will you take its probability? 24 by 30 into 24 by 30 into 24 by 30. You simplify it, you will get the same value, that is 256 divided by 625. Now the third case, 2 defective and 2 good bulbs. So we can take 2 defective and 2 good. So it is 4Z2. So probability of x is equal to 2 is given by 4Z2 into, then you write the probability of defective bulbs, that is 6 by 30 into 6 by 30, then 24 by 30 into 24 by 30. Then you simplify it, you will get 96 divided by 25. Then this one, third case, fourth case, that is 3 defective and 1 good. 3 defective and 1 good. For 3 defective can be chosen in 4C3 ways. So we write probability of x is equal to 3 is equal to 4C3 into 6 by 30 into 6 by 30 into 6 by 30 into the last two are always good one. So it is 24 by 30. Now you simplify it. You can simplify easily and your answer will be 16 by 625. Then we come to the last case, that is 4 defective. Means there is no good bulbs, all bulbs are defective bulbs. So we write probability of x is equal to 4. That is only one way, that is 4C4 into 6 by 30, 6 by 30 into 6 by 30 into 6 by 30. You simplify it, you will get 1 by 625. So after completing all this, we come to the probability distribution. Here we can write the probability distribution like this. Let x denotes the number of defective bulbs and x can take values 0, 1, 2, 3, 4. Now you fill the table, that is x the values are 0, 1, 2, 3, 4. Then probability of x is 256 divided by 625, 256 divided by 625, 96 by 625, 16 by 625, and last is 1 by 625. Here you have to add all this, that is the total probability, and check whether it is 1 or not. It is 1, your answer is correct. Okay. There are two more questions for doing yourself. The first one is this one. Find the probability distribution of the number of doublets in 3 throws of a pair of dice. So you know doublets. When you throw pair of dice, that means we are throwing 2 dice together. Then you know there are 36 outcomes, and how many doublets are now? You know there are doublets. They are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. They are known as doublets. So they are asking, we are throwing it 3 times. If so, what is the probability distribution of the number of doublets? You underline the number of doublets. Since we are throwing it 3 times, it cannot exceed the value greater than 3. So the number of doublets, when you throw it, it may be 0, it may be 1, it may be 2, it may be 3. Okay. So you prepare a table for it and write it as just like this. That is probability distribution of x. So do it yourself. And one more question. A random variable x has the following probability distribution. So the probability distribution is given as a table. And x can take values 0, 1, 2, 3, 4, 5, 6, 7. And p of x is given in terms of k. That is for 0 it is 0, 1 it is k, then 2k, for 3 it is 2k, then 3k, for 5 it is k square, for 6 it is 2k square, and for 7 it is 7k square plus k. Now based on this probability distribution, there are 4 questions. We have to answer it. Determine the value of k. First question is find the value of k. You know how to find the value of k. You know the total probability. We studied it. You make an equation and find the value of k. Then you will get the first question. Now in the second case, what you have to do? The probability of x less than 3. It is given that the variable is less than 3. So you have to consider the first 3 cases. That is 0, 1, 2. Then you take the sum. That is 0 plus k plus 2k and substitute for k. Then you will get the value of second question. Then what about 3? In 3, we need probability of x greater than 6. That means the random variable is greater than 6. There you have to take 7. Okay. Then what about the last one? Fourth question, that is probability of 0 less than x less than 3. That means x lies between 0 and 3. So there are only 2 values in between 0 and 3. That means you have to take 1 and 2. Okay, got the idea? Do it yourself. Now I give you another homework, that is based on Bayes theorem. We have done so many problems. Now this problem you have to do it yourself. This is based on Bayes theorem. And suppose a girl throws a die. If she gets 5 or 6, she tosses a coin 3 times and notes the number of heads. If she gets 1, 2, 3 or 4, she tosses a coin once and notes whether a head or tail is obtained. If she got exactly 1 head, you underline, she got exactly 1 head. What is the probability that she threw 1, 2, 3 or 4 with the die? So as above, here you have to define what is C1, then what is C2, then A is very important, the event occurred. Then what are the remaining steps? Find P of E1, then P of E2, then P of A given E1, then P of A given E2, and then you write the required probability condition and put a question mark. Then use the formula of Bayes theorem. I think you can follow this and you can do it yourself. All the best, all dear students. Thank you all. Here we finish our chapter, the probability theorem. Okay, probability theory chapter is very important. The problems are very simple. You can score full mark from this chapter. Okay, thank you all.